Legionnaire's disease is a national priority for HSE. You will all be aware of the major outbreak in southwest Edinburgh in 2012, which is thought to be associated with cooling towers in the city. That outbreak took the lives of 4 people. Overall, 56 people were confirmed as having contracted Legionnaire's disease, with a further 36 suspected cases, bringing the total number of people affected to 92. 2012 also saw an outbreak of Legionnaire's disease in Stoke-on-Trent, in the English West Midlands. There were 21 cases with 2 deaths. The probable cause was a hot tub on display in a warehouse. HSE's actions are focused on improving the awareness of duty holders of risk systems, and a safety notice was issued in respect of cooling towers and other wet systems in 2012. Considerable effort has gone into inspecting cooling towers, and some of you will have already been involved in that initiative. We can expect further initiatives to follow. HSE identify the following as Legionella risk systems. Cooling towers. The one on the right was the cause of the Legionnaire's disease outbreak in Glastonbury in 2003. Hot and cold water systems, spa pools, and other risk systems. The last category includes humidifiers, air washers, emergency showers, eye wash sprays, indoor ornamental fountains, aqueous tunnel washers, etc. that could potentially be a source for Legionella bacteria growth. This is an example of a humidifier installed in a Morrison's supermarket in Colchester in Essex. Even windscreen wiper fluid without added screen wash in vehicles has been suggested as a risk factor for Legionnaire's disease in drivers. So, what makes a risk system for Legionella, and why are spa pools a problem? Legionella are ubiquitous worldwide and survive in aquatic and moist soil environments as intracellular parasites of free-living protozoa. The bacteria are acid tolerant and have been isolated from environmental sources ranging from a pH of 2.7 to 8.3. Legionella have been found in sources as diverse as water on plants in rainforests, in groundwaters, and in seawater. Legionella may be present in natural water sources at levels too low to be detected using culture methods. Such water can potentially introduce Legionella into storage tanks and systems in the built environment, where the physical and chemical conditions encourage their growth. Legionella multiply freely in water systems when they are provided with nutrients and a temperature range between 25 degrees C and 45 degrees C, with an optimum range for Legionella pneumophila of 32 degrees C to 45 degrees C. Legionella do not multiply at water temperatures below 20 degrees C and are destroyed above 70 degrees C. Legionellosis, which includes Legionnaire's disease and Pontiac fever, is acquired when droplets of water containing Legionella are inhaled. Men are more likely to become ill than women, and older people than younger, and anyone whose immune system is compromised. Legionella risk systems, therefore, are water systems which have a water temperature between 20 and 45 degrees C, create and or spread breathable droplets, store and or recirculate water, are likely to contain a source of food for the organism, such as the presence of sludge, scale, or fouling. This hot tub illustrates all of those factors. Warm water encouraging the growth of bacteria, nutrients from bathers such as dead skin, sweat, and other bodily secretions, bath oils, body lotions, soaps, etc., an aerosol created by aerated water. This list shows some of the more significant outbreaks associated with spa pools or hot tubs. It is important to note that pools on display and not being used are still capable of causing outbreaks of legionellosis. The Stoke-on-Trent outbreak was one of those cases. One of those spa pool outbreaks happened at Loch Head in Argyll in 1987 to 1988. This was a non-pneumonic form of the disease caused by Legionella mcdadii, which was subsequently named Loch Head fever. There were 170 cases of illness in 187 individuals who had visited the leisure complex, and 91% attack rate. A report was published in The Lancet in 1989. This paragraph from the discussion in that Lancet report is self-explanatory. We believe that the faulty bromination system allowed the accumulation of L-Migdadii in the whirlpool water system. The most likely explanation for the outbreak is that an aerosol containing L-Migdadii disseminated throughout the enclosed pool area and through the frequently open door to the lounge, which was visited by all 187 individuals. Large numbers of cases associated with spa pool outbreaks are not uncommon. Health and Safety Laboratory published data on outbreaks of Legionellosis in Great Britain over a 10-year period, which is summarized in these next two slides. You will note the relative proportions of risk systems where a cause has been identified, and that hot and cold water systems are predominant. The grey segment at 7 o'clock are spa pool outbreaks. It's a different story when the numbers of cases by each risk system are considered, when spa pools emerge as the cause of the outbreaks with greater average number of cases. The significant factor for Legionella growth and survival in water systems is the presence of biofilms. In hot tubs, air and water circulation systems provide a large surface area for biofilm, and those biofilms are resistant to disinfection. Biofilms will form in any situation where waterborne microbial flora are in contact with the surface. Microbial biofilms are extremely complex heterogeneous microbial ecosystems and may consist of bacteria, algae, and grazing protozoa. Biofilms facilitate nutrient and gaseous exchange and protect microorganisms not only from biocides but also from periodic increases in temperature and attempts at physical removal, especially in areas where surfaces are scaled or corroded. Biofilms are more likely to form where there are areas of low water flow and where water is allowed to stagnate, hence the critical importance of eliminating dead legs in hot and cold water system. Within a biofilm, microorganisms are embedded in a cellular matrix that provides structure, stability, nutrients, and protection from possible toxic effects of the substrate upon which the biofilm grows, for example copper pipes in distribution systems. Legionella grown in biofilms are more resistant than the same bacterial species in the water phase of the system. Legionella don't actually grow and multiply particularly well in the planktonic stage. They are facultative intracellular parasites and prefer to take advantage of the nutrients that are available inside amoebae and other protozoans. This slide illustrates the life cycle of Legionella bacteria within protozoal cells. You'll note that this is the same method they use to proliferate in human white blood cells. Interestingly, what happens to the Legionella bacteria once they are ingested by amoebae depends upon the temperature. At 22 degrees C, the amoeba has the upper hand and the bacteria are food. At 35 degrees C, the bacteria can proliferate inside the amoebae. More of the Legionella bacteria grow flagellae as the temperature rises from 30 degrees C to 35 degrees C, and flagellae appear to increase the infectivity of the bacteria. Protozoa protect Legionella from the effects of biocides in normal concentrations. The Legionella bacteria have even been found in encysted amoebal cells. Biofilm prevention is therefore an important control measure against proliferation of Legionella. Preventing the growth of biofilms in the first place is important because once established, they are difficult to remove from complex piping systems. This view of the underside of a spa pool installed in a leisure complex shows some of the extensive pipework associated with circulating water and air in the pool. This pool is about 25 years old, and the pipework has been modified by the users in that time. If we zoom in on this area, we can see some of the potential problem areas for biofilm control. This could be a dead leg. Corrugated flexible pipes trap water in the valleys of the pipe, making cleaning and disinfection more difficult. Washers and gaskets are another area where biofilms can establish and be difficult to remove. And remember, there are other microbiological hazards associated with spa pools and hot tubs. These include Pseudomonas aeruginosa, Mycobacterium species, acanthamoeba, which can themselves ingest Legionella bacteria and protect them from disinfection, cryptosporidium, and hepatitis A.